talking about the areas of triangles. So if you have any triangle, let's say ABC, in this case, then we say that for any triangle, the area is equal to half times the base times the height. And we know that height is with reference to which dimension of a triangle you consider as base. So if I consider base as BC, let's say this dimension is x units, then the height will be the perpendicular distance from the vertex which is directly opposite to this line segment BC, correct? And let's say if this height is h, then your area in this case would be half times x times h, whatever those units are. So we'll call this as in square units, correct? So this is the general formula for the area of a triangle, correct? Now let's say you are given a right angle triangle, okay? So this is my right angle triangle. Let's say this dimension is DE and then we have F. If you consider EF as the base, let's say this is X, then the line segment DE becomes height itself because it's at a perpendicular distance from this base EF, right? And this is the shortest distance from the vertex D to this line segment EF, right? So we still apply the same formula in both cases. What if, let's say, you are given an obtuse triangle? So obtuse triangle is one in which one angle of a triangle is greater than 90 degree, right? Such as the one shown right here. So let us say this triangle is J, K, and L, and vertex K is the one that has angle greater than 90 degree, okay? In this case, this height H is outside the triangle JKL, okay? That is the only difference between an obtuse angle and the way it appears, the height in an acute triangle, correct? But either way, the formula for the area of a triangle, that won't change, okay? So with that, let us go and practice some problems to strengthen our understanding on the concept of area for a triangle. Let us consider this problem in which triangle ABC, it's a right triangle and the right angle is right here at vertex A, okay? So we have been given the distances of all three line segments and we are supposed to compute this height h. In addition to that, we want to compute the area of this triangle, okay? So we have identified what we need to compute and we already have the diagram, correct? So let's go ahead and work on the solution plan. So first let us compute area. The area of a triangle is equal to 1/2 times base times the height, right? And if I take AC segment as the base, which is 12, then I already know the height because it's a right angle triangle. And in case of a right triangle, we know that the line which is perpendicular to the base makes the height, correct? So this will be equal to 30 centimeter square. Okay, so we know the first part, the area. Now, once we know the area and we know that there is a base BC, we can compute the height AD, and that will be very simple then. So in this case, my area is equal to 1/2 times the base is BC, which is 13 times the height h. We have everything except this one unknown value, a simple transposition of some values. So h is equal to 30 times 2 divided by 13. And this value comes out to be 4.615 centimeter. Okay, so very simple application. Compute the area and then compute the unknown. In order to compute the area, you needed the base and the height. And from the right triangle, we could do that. Alright, so in this problem, we have the legs of a right triangle are in the ratio 3:4. And the area is 1014 square centimeter. Find the length. Okay, so this seems a little bit of a complex problem because we are given the area and we are given the ratio of two legs. We need to find the length of its legs for a right triangle, okay? Now let us draw a diagram to understand this problem a little better. If this is my right angle triangle, triangle A, B, and C, and the ratio of the two legs, what are the two legs of a right triangle? The legs are AB and BC, the two sides that make right angle. Now for this triangle ABC, we don't have the actual dimensions, but we have this ratio BC to AB is equal to 3:4. So let us say if BC is equal to multiple of x, let's say it is 3x, then with that concept of a ratio, this dimension AB will be 4x, right? That way it's going to preserve the ratio into 3:4 ratio, right? So we have this general idea of what those lengths are going to be, 3x and 4x, and we need to find this unknown value x. Okay, so now we know what we need to find. Let's compute the values then. So we know that the formula for an area of a triangle is half times base, let's say the base is BC, 3x, times 4x, which is the height, correct? And 2 will cancel with 4, it becomes 2 here, and this becomes 6x square. So now we have the area of this triangle in general form. We don't have the exact value, right? But we know that the area is also equal to, given from here, 1014 centimeter square, right? And wouldn't that make an equation from here to here? Now we have one equation, one unknown value, and we can simply solve it. So let's rewrite this whole thing. X square becomes 1014 divided by 6. That comes out to be 169, which implies x square is equal to 169. Now if I simply put a square root on both sides of this equation, I can do that. That way the equation still remains balanced. That will give me the value of square root of x square is equal to x, and square root of 169 is 13, correct? I'll simply substitute this value of x in this ratio, okay? So that way I get the 3x is equal to 3 times 13 from here, and the other dimension is 4x. That will be 4 times 13 from here, right? This 13 is substituting here, and this 13 is coming here. So that means, what are the dimensions then? So the dimension BC is equal to 39 centimeter, and the dimension AB is equal to 4 times 13, that becomes 52 centimeter. So we have our dimensions. So this is how you will apply the knowledge of area and the calculations, and how do you apply that to understand various dimensions of a triangle.